Can stories help you to learn C++ multi-threading? The answer is yes. Not only because these stories are interesting, but also because these stories tell you design patterns, patterns that are most critical to multi-threading programming. In this serial, I will tell you 5 stories that can help you to master multi-threading programming. This story helped me tremendously before, because these stories actually tell 5 design patterns that are critical for multi-threading programming. In this video, I will not only explain what these 5 patterns are, but also share the source code to you so that you don't have to start from scratch. This is a third video of this series. In the last video, Danny learned about the condition variable design pattern. If you haven't watched that video, and if you don't know about what condition variable is, I suggest you to pause this video and go back to watch that video. I put the link there or down below. Because condition variable is a foundation of the design pattern we are talking about in this video. Okay, since now you understand what condition variable is, let's continue our story. After learning condition variable, Danny was extremely happy. And he started making good money because he actually expanded his collection of stocks. He found that he got 20 stocks to manage, and it has become a nightmare for him because he needs to watch 20 condition variables. And this is also a nightmare for Peter because Peter needs to update, give him an alert on 20 different stocks. So apparently this is not sustainable. So one day Peter actually called Danny and said, why don't you, Danny, just purchase the stock price watcher service from the stock exchange? All it does is to send you the text message of the price change for the stocks you are interested in real time. All you need to do, Danny, is to watch the text message on your cell phone. And for example, if the price is higher than $90 on Apple, you sell it. Otherwise, you just delete it, right? So you keep reading the message, and after you process the message, you just delete the message. If all messages are processed and your cell phone become empty, you can go back to work. Is that simple? And then you think about it and think, this is brilliant. Now, instead of watching all those 20 different condition variables, all I need to do is just keep watching my cell phone, the text message, and I get those messages in real time. And if no price change, I can go back to my work. Thank you, Peter. That's a brilliant solution. And Peter said, hey, bro, don't thank me. I actually got this idea from an architect. He told me this is a design pattern. He called it the monitor pattern. The monitor pattern has 2 key components. The first one is a message queue. You just can think as the text message on your cell phone because they queue up all those text messages one by one. And then the second component of this design pattern, Danny, guess what? It's you. Because you are one single person keep watching those text messages and to process those messages, right? So you represent one single thread in our computer system. So in the computer system, you taking out one message and process it, take out another message and process, and do it again and again until the message queue becomes empty. And if that happens in real life, Danny, you will go back to work. But in our computer world, the Danny thread or the processing thread will be blocked by this empty message queue. And once there's no message coming into the queue, the process thread will be woke up and then start processing the new message. So just like in real life, Danny, when a new text message comes in, your cell phone will vibrate and notify you so that you can start process the new text message. So now let's translate our story into code. So our story is in the test stock message update function. Within this function, we just create the message queue, which I will explain later. And then we make a producer thread, which is responsible for producing stock price changes. And then the Danny thread, which will keep reading the price changes from the message queue. And that's it. Let's take a look at our producer thread. What it does is produce 10 different stock messages and pump them into the message queue. And then it will send out a market close message, which sets the stock price to -1. So in the Danny thread, it keep looping and reading message from the queue and then process it. If it reads a market close message, it will break the loop and end the thread. So now the key question is, what is a thread safe message queue and how do we implement that? So a thread safe message queue means three things. Number one, the producer thread and the consumer thread at any point of time, only one of thread can access the message queue. What this means is that we must have a mutex to protect our message queue. Number two, when the consumer thread, which is our Danny thread, will be blocked if the message queue is empty. The Danny thread will only process a message when the message queue has messages. This is logically simple to understand, right? Number three, we have something similar to the producer thread. The producer thread will be blocked if the message queue is full. For example, if we allow maximum 10 messages can be put into the message queue, and when the producer thread has the 11th message, it cannot put into the queue because it's full. The producer thread will be blocked until the consumer thread process some message and remove these messages from the message queue, and then our producer thread can continue to pump in new messages. So these three key features guarantee that the message queue can work safely under multi-threading environment. And let's take a look at how we implement this message queue. By the way, you don't have to implement your own message queue because there's tons of free library and framework you can use. But understanding how message queue is implemented is extremely helpful for us to understand how mutex work and how condition variables work. Especially in this case, you will see two condition variables collaborate each other. So here's our message queue. It's basically a standard library queue which takes any message type defined by the template class type. And then it has three data members mutex, which we understand is used to protect our message queue, and two condition variables. The first one is the in-queue condition variables. If the message queue is full, the condition variable will block the producer thread. The other one is the DQ condition variable, which is used to block the consumer thread when the message queue is empty. So the message queue has two key member functions. The number one, in queue, which is to put a new message into the queue. What it does is to lock the message queue first, and then to see if the message queue has exceeded the limits, the maximum message numbers. If it is, then it will wait on the lock. And once it wake up, which means that somebody removes the message on the other end of the queue. And then the producer thread has a chance to push new messages there. After it does it, it's guaranteed that this message queue has at least one message. That's why it sent out a notification to wake up any thread that is being blocked on the consumer side. And the second key API of message queue is DQ, which is take out a message from the message queue so that the consumer thread can process the message. So the same thing, it has to lock the message queue first and then to check if the message queue is empty. If it does, then the thread has to be waiting on the condition until the queue becomes not empty. So if it's not empty, it will dequeue one message and process it, and then notify and wake up the producer thread that is being blocked by the condition of message queue is full. So that's a whole story about the message queue, and let's run the code and see what the result is. We compile it and we run it. So let's analyze what the output means. So first, the producer thread print out the message says it adds the stock price at $7. And then Danny reads that stock and bought the stock at $7. And then the queue becomes empty. So the Danny thread is blocked to wait until a new stock is added to the message queue, which is $73. And then Danny's thread woke up and reads the new message, and it goes on and on until the market is closed. So now we know what the monitor pattern works. As before, I will put the link of the source code down below. But if you think about it, Danny just one customer for the stock exchange. The stock exchange will handle hundreds of thousands Danny, if not hundreds of millions Danny. How do you scale a process from just handling one person to hundreds of thousands or even hundreds of millions users? The next video, I will introduce the most important design pattern that can give you the most important weapon to attack this issue. If you like this video so far, please subscribe and like this video, and we can make more people to watch this video. Thank you. This channel is all about digital transformation and technology. If you are interested in these topics, please join our community down below, where you can discuss these topics with other people with the same interest.